Okay, so let's talk about stoichiometry. Basically, when I was an undergraduate, they talked about cookbook chemistry, and that's because baking or cooking has a lot of similarities to stoichiometry, which is one of the major types of calculations we do in chemistry. So, how do chemists use balanced chemical equations? I know a lot of you, because of the coronavirus, are at home. You're cooking at home, you're eating at home. You have to go to the grocery store and buy enough food for a particular recipe. You have to have all the ingredients. And you have to have, at the end of cooking that dinner, enough to feed all the members of the family. And so that is very similar to what we do in stoichiometry. So we use balanced chemical equations so that we can calculate how much we need as a reactant, the ingredients for our recipe, and how much product are we going to make, enough food to feed the family. So when you know the quantity of one substance in a reaction, you can calculate how much you need of anything else in that same reaction. So calculations of of chemical equations is a subject called stoichiometry. Very weird word. So, chemists use stoichiometry as kind of a bookkeeping or a recipe. And it allows us to tally the amounts of reactants we will need, how much products we will make. And so we can either use moles or representative particles. We can use all sorts of things. So, Kayla is using a recipe to make chocolate chip cookies. She wants to double the number of cookies that the recipe will make. The original recipe calls for 2 cups of chocolate chips. How many cups of chocolate chips should Kayla use to double the recipe? This is a really simple question, but it does get to the heart of what these calculations are all about. So if she needs 2 cups for one batch, she'll need 4 cups for a double batch. In terms of the quantities, can you interpret a balanced chemical equation? And there are lots of quantities we can use. So here's ammonia is produced from nitrogen and hydrogen. We have a balanced chemical equation, and it tells us exactly how many products and reactants we need. And what units we use will be very important. I know I'm always stressing units, but I'm still stressing them today. So, how can you determine the amount of each reactant that you need to make a product? Well, a recipe or an equation, such as the balanced chemical equation, is used to determine how much starting material is needed or how much product will be made. A balanced equation can be interpreted in terms of different quantities, including atoms, molecules, moles, mass, and volume. And so to kind of tabulate all that with a particular chemical reaction, here we have N2 plus 2H2 yields 2 NH3s. On the first line, we see the particulate view or the atom view. We have 1 molecule of N2, we have 3 molecules of H2, and we get 2 molecules of NH3. The next line down tells you in terms of atoms. The next line down tells you in terms of molecules. The next one says, what if I multiplied it by 10? What would I have? And what if I was looking at how many molecules in a mole? And so I would multiply each by Avogadro's number. Then we can look at moles, we can look at grams, we can look at grams of reactants to grams of products, and those two numbers always have to be equal because the law of mass action applies, or we have to conserve mass. And since all of these are gases, if we were at STP, we could tell how many liters we would have of each one. And that would be important because if you make more moles of gas than you start with, you have to allow for that expansion. So, mass and atoms are conserved in every chemical reaction. Molecules, formula units, moles, and volumes are not necessarily conserved. They may or may not be. If you look back here, You'll see on the left side of our reaction we have a lot more moles of gas than we do in our moles of product. And so we also don't have the same liters of reactants as liters of products. So, and we'll notice if we look up at molecules, we don't have the same number of molecules being made in this reaction, but we do have the same number of grams. So, grams and atoms must be conserved, and that's something I would definitely write down. So, interpret the following reaction in terms of volumes of gas at STP. So, if I'm at STP, I would have 22.4 times 2 liters of hydrogen. I'd have 22.4 times 2 liters of NO. I'd have just 22.4 times 1 liters of N2, and I'd have 22.4 times 2 liters of hydrogen. And so we would have these numbers. And again, those numbers are not conserved. They're not the same on both sides. And that's because how the molecules or atoms are put together. So, look at that. We finished 11.1 already. Balanced equation provides the same kind of quantitative information that a recipe does. Chemists use balanced equations as a basis to calculate how much reactant is needed or how much product will be formed. Balanced chemical equations can be interpreted in terms of different quantities, including atoms, molecules, mass, moles, volume. Of those, only atoms and mass are conserved. I've said that 3 times. That should give you a clue that it is very important. Mass and atoms are conserved in every chemical reaction. Volumes, etc., are not. Stoichiometry is that portion of chemistry dealing with the numerical relationships in chemical reactions, the calculation of quantities of a substance involved in chemical equations. Big idea. Balanced chemical equations are the basis for stoichiometric calculations. The coefficients of a balanced equation indicate the number of particles, moles, volume of a gas of reaction. And that's the end. Thanks for listening, guys. I hope to see you sometime soon.